Hi, it's Mr. Anderson, and in this podcast, I'm going to talk about carbohydrates. When I say the word carbohydrates, you might think about the starch that's found in this bread or maybe in this pasta. As a biology teacher, I immediately think of sugar because that's going to be the building block upon which most carbohydrates are made. But you should also know that aside from providing energy for us, they also provide structure. And so cellulose that's found in plants is going to be a polysaccharide, or the chitin that's found in the exoskeleton of an insect or the building block of fungi is going to be a carbohydrate. And so they give us energy, but they also give us structure. Sugars in science we call saccharides. And the reason I wrote carbohydrates inside these hexagons is that that's how sugars are essentially put together. And so if we have just one of these sugar molecules, we call that a monosaccharide. So an example could be glucose. If we have two of them together, we call that a disaccharide. An example could be table sugar or sucrose. It's actually one glucose and one fructose molecule. If we have about 3 to 10 sugar molecules, we call that an oligosaccharide. And then if we have a whole bunch of sugar molecules attached together, we call that a polysaccharide. And so glycogen would be an example of that. And so basically, the empirical formula of all carbohydrates is going to be the same. In other words, we have a ratio of 1 to 2 to 1 in the amounts of carbon, hydrogen, and oxygen. So we have twice as much hydrogen as we do carbon and oxygen. Can you see why they're called carbohydrates? We've got a carbon out here, and then we have water. So it's a carbohydrate. Good way to remember that. If we look at a simple monosaccharide, it's going to have 6 carbon, 12 hydrogen, and 6 oxygen. And so the simplest, the sugar upon which life is built is called glucose. And so glucose has 6 carbons. We could look at them. There's one here, 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 and here. So they're going to be at the junction points on this ring. In an aqueous solution or in water, they're going to form these rings. But you can also see that there's going to be a lot of oxygen. So we have all these hydroxyl groups around the outside. And that makes sugars readily dissolvable in water. And so glucose is used in cellular respiration. It's produced by plants in photosynthesis, so they can use it in respiration, so it's the building block. A lot of the different sugars that I'm going to show you in this podcast are built upon glucose. But there are other ones. We've got the fructose. Fructose is going to be you can see it's a 5-sided sugar. It's going to be a little sweeter than glucose, and it's going to be found like in fruit or high fructose corn syrup. And then we have galactose, and galactose is going to be a little less sweet than glucose. But these are the basic 3 monosaccharides. What's cool about these, they all can readily be moved into our blood supply. And so these are flowing through your blood right now, these little monosaccharides. If you ate pasta, for example, we first have to break that down into its monosaccharides before we can move it through the blood and then into the cells in our body. So what are disaccharides then? Disaccharides are going to be 2 sugar molecules attached together. And so the table sugar that's found in these sugar cubes is going to be sucrose. And so it is a glucose molecule attached to a fructose. And so when that goes into my body, I have an enzyme called sucrase that has to break that down into its monosaccharides before I can actually use it. Or here's another one. The milk sugar, so lactose, is going to be a glucose and a galactose chemically bonded together. And so if you want to break down lactose, you have to have an enzyme called lactase. Now, if you're lactose intolerant, what does that mean? You just lack the enzyme to break lactose down into its 2 monosaccharides. And so you're going to feel a little irritation in your gut, and that's because we can't break it down. Now, that seems to be, there's some really cool studies you could read on lactose tolerance or intolerance, and it's been naturally selected. In other words, if your ancestors had domesticated cattle, it made sense for them to drink milk later on in their life. But most people just drank milk when they were young, and so they quit producing that lactase enzyme. Okay, let's go to oligosaccharides. Oligosaccharides are going to be like 3 to 10 different sugar molecules. They're important in biology in one pretty important part, and that is in the production of these, which are called glycoproteins. So we're in a cell membrane. And these, which are going to be glycolipids, if you look at the glyco part, or the sugar part, that's going to be just a few sugar molecules attached together. And these are really important, for example, attaching to the extracellular matrix. They're important in identifying what type of a cell it is. Here's an interesting note I learned on Wikipedia. If you were to eat carrots are a wonderful source of oligosaccharides. However, you can't get the sugar molecules out of it until you've cooked the carrots for about an hour to release those oligosaccharides. But again, if you're not getting them in your diet, we can synthesize those inside the cell. Now let's look at this number right here as we go from oligosaccharides to polysaccharides, and look how much that jumped. And so when we're talking about starch, for example, what is starch? Starch is going to be hundreds of these glucose molecules attached over and over and over again. And so the starch that's found in a potato, or if we dry it out, it's going to look like this, is going to be hundreds of sugar molecules attached over and over and over again. Now, why are plants doing this? Why are they making these large molecules? They're storing energy in the starch molecules, so they can use it by chopping it down into individual monosaccharides. Now, can we do that? You bet. We've got glycogen. So glycogen is essentially a macromolecule, and so it's going to have thousands of glucose molecules attracted together or chemically bonded together. You can see how monstrous this looks with all these individual glucose molecules, and we're going to store that in the liver. And so if you are carbo-loading, what are you really doing? You're eating a bunch of starch, you're breaking those down into monosaccharides, and then you're reattaching those again, and you're storing them in our liver as glycogen. And so we can get to those stores eventually when we need it. We can chop up those monosaccharides and we can use them in the cell. But we also get structure, remember, and so cellulose that makes up that structure in a lot of plants. You can see here it's going to be a bunch of sugar molecules attached over and over again, but we're going to have these hydrogen bonds that cross bond between the different polysaccharides. It makes them incredibly durable. If you were to eat wood, but you don't have the enzymes to break it down inside your gut, and so it's going to go in as wood and it's going to come out as wood. And so if we want to break down cellulose, we have to get help, and we have to get microscopic help. And so like a cow, for example, is going to have a bunch of bacteria and other microscopic life that lives in their gut that can break down that cellulose, and so they can eventually get to sugars. But it's not that easy. So how do we do all this building, and how do we do all this breaking? Well, there's basically two processes. Since it's a polymer, we can use hydrolysis. Hydrolysis is simply breaking the sugars. And so right here we have a lactose molecule. You can see it's a disaccharide. And so what we can do is we can add a water. And when we add a water, we can break this bond right here, and we can make two monosaccharides. And so hydrolysis is simply breaking them apart. Enzymes help on this as well. And then a dehydration reaction is when we're going to have two monosaccharides and we go in the other direction. So when we're actually making lactose, we're taking two monosaccharides, we're losing a water, and then we're making that covalent bond between them. And so again, we can build, we can make them smaller, and then we can eventually break them down in respiration. Now, if we were to look at sugars, are they a good thing? Well, evolutionarily, they're very important. Why do we love sugar so much? It's because sugar is usually an indicator of fruit, and fruit is going to have a lot of other vitamins in it that we need. And so humans are essentially programmed to love sugar. Sadly, what we've done is we started to put sugar in everything. And so this, I didn't even know this. They made this. This is a double big gulp. So if you had this much soda, it's made of high fructose corn syrup. So basically, we're enzymatically breaking down corn to make this fructose, this really sweet sugar. And it's killing us. We're seeing an increase in heart disease, an increase in diabetes as a result of that. And so a little bit of sugar is good. We need it for energy, obviously, but too much is probably bad. And I hope that was helpful.